In this episode of Finnugric Machining, well, it will be the upper roller for this craft die press. There are a few problems with this. Wait a minute. Well, first of all, this is the stock. It's going to be 210 millimeters long. This is now 250. I just cut it off with my angle grinder. And the outer diameter, if I recall right, it's 39 millimeters, and it should be really precise. And there will be a hole through 17 millimeters and then places for bronze bushings at the ends. There is one more feature for this one which comes later because it cannot be done now. Later. So, this one, if you think you could probably chuck it in a lathe and then turn it and then turn it around and then turn it again and hope that it's still concentric. Well, no. Instead, the way to go with this one is this. This is a lathe dog. And those of you who have been doing things a long time know what this is for. So this is the very first time I'm going to turn this one between centers. So, let's go on and try this one too. This is going to be very exciting. So, lathe.
That's not my lathe. The lathe dog was a tiny bit too large for my lathe, so I had to shorten the unnecessarily long bolt. I make this compatible with my multifix wrench. The diameter seems to be in the neighborhood of 16 millimeters, so I have to take 2 millimeters per side to get it suitable for the 12 millimeter wrench. I will first mill two opposite sides so I can measure it and adjust the cutoff depth if needed. Then I just mill the remaining 4 sides.
Gotcha.
the wrench fits as it should. Here I'm removing the burr and making it look like a tool. My chamfering tool decided to self-destruct. Well, seems like I have some more practicing to do with silver soldering and brazing. Now, this is a suitably loose fit. Now I'm making the center for the headstock side. The material is chrome moly and I'm turning it down to fit into a 20mm collet. Now I'm facing and drilling center holes on both ends of the workpiece. I'm changing over to the collet chuck. I orientate the adapter the same way every time. This makes it easier to align the collets, and it may also have some impact on run out. Workpiece had an existing centre hole which I need to get rid of before I can machine the center cone into it. I turn the compound to a 30-degree angle and then machine the center cone by feeding with the compound. I file a dent at the side of the center to be able to put it back the same way it was created. This may improve concentricity.
Yep.
Now I'm attaching the workpiece between the centers. I was really lucky with the bolt thread location in my lathe dog. It is located conveniently right over a hole in the lathe spindle. I am using a short piece of rubber tube over the bolt to minimize rattle and protect the lathe spindle from scratches.
Yeah. Okay.
Now I'm setting up the carriage stop to avoid accidental collision with the lathe dog. The downside of turning between centres is the poor rigidity. I am using a Cermet insert that has very low cutting forces. I also use slow spindle speed, shallow cut and slow feed. Here I am mapping the deviations in the diameter of the workpiece. I use these values when I adjust the tailstock to eliminate the taper. I measure the alignment of the workpiece from its backside. My goal is to halve the figures I just wrote on the workpiece. This is done by adjusting the tailstock sideways. The taper cannot be entirely eliminated because the taper is not linear at the headstock end. Now I am turning the workpiece into its final diameter. I first turn a short band at the beginning of the workpiece. Then I measure this band and adjust the diameter if needed. After that I machine the rest of the workpiece diameter. Turning between centers allows the workpiece to be turned around without losing its concentricity. Here I'm turning the rest of the workpiece to the correct diameter. Now I am drilling a 17mm hole all the way through the workpiece. I start with a 10mm stub drill to make the center hole angle compatible with a twist drill. Now I make a 10mm deep hole with an ordinary 8.5mm twist drill to guide the very long parabolic twist drill. I try to support the workpiece from the side to keep the workpiece as concentric as possible. I really need a steady rest. Now I am using this really long 8.5mm parabolic twist drill to drill a hole through the workpiece. Lastly, I use a normal 17mm twist drill. The hole must be drilled from both ends of the workpiece, as the drill does not reach all the way through. this trick to set workpiece length from Curtis at Cutting Edge Engineering Australia. As obvious as the trick is, it revealed itself to me only after watching his video. Thank you, Curtis. First, I push and fasten the workpiece against the base of the chuck. I reset the compound dial and locate the compound in such a way that I know the correct zero location. I gently push the tip of the lathe tool against the base of the chuck. The tool tip is then at the same level with the workpiece end. Now I reset my travel indicator. Those who have a DRO would like to reset their DRO. I set the location of the carriage to the correct workpiece length with my travel indicator. When I'm quite sure about the location, I lock the carriage at that place. After this, the lathe tool is at the correct place and I can use the compound to advance cutting place during my phasing operation. I am now phasing the workpiece to its final length. The stick out is pretty impressive, so heavy cuts are not possible. The last cut is made with a heavily tilted tool to achieve a good surface finish. This is definitely not one of my brightest ideas. The intention here is to make the bushing recess concentric with the roller circumference. I thought that I only need to set up this once and do the other end with the same setup. In theory that should work, but as it occurred to me, we live in the real world.
This workpiece, well, the holes at the ends where the bushings go should be concentric with the outside. At the moment they are not. The other one is, the other one isn't, because my vice didn't repeat. I cleaned it up thoroughly, but still it didn't. Well, I have to make these holes bigger and then measure it before actually milling the hole. Well, why don't I do this in the lathe? Well, the answer is really simple. I don't have a steady rest. That would, of course, solve the whole problem. But as it is now, I have to deal with this like that. Well, another option would be to use my four-jaw chuck. It would go quite deep into that one. Well, I'll think about that, because this one you can then make really concentric. Well, actually, now when I think about it, it's probably the way to go. So, four-jaw chuck, and dial it in and then bore it straight. Okay, but that will be in the next episode of Pinno Brick Machining. Well, till then, bye!
Charlie Vatsa.
What now?
Rasivo jopsoja voh.
You don't mean. Okay.
So it was decided not to postpone this operation into the future. Now I am using my orbital sander to get certain type of finish on the workpiece. I am using the rubber mat over my waist to protect them from grinding dust. The orbital sander swallows most of the dust, but some of it always escapes.
So now this is ready. Well, almost ready. There will be a gear at the other end, and it must be keyed to this somehow so that it well, rotates it. But I don't make that keying before I have the gear. Tends to drop. Okay. So, in the next episode we won't be turning this one in with the Hoja chuck. It's already done. I also gave it this finish, which is not like shiny. I want it to be so that it grips better on paper. If it would be like a mirror finish, that's bad. It doesn't grip on paper, and this is essential with this one, so that it really doesn't slip there. Okay, so now, well, in the next episode we are going to make the lower shaft, and this one will also be turned between centers. And well, in a way, let's see. I now have the Hoja chuck there, which is sort of heavy. Well, I was lazy, really lazy, so I didn't want to lift it. But it's not that heavy. It's only about 25 kilograms, and well, okay. Anyway, so the lower shaft next episode. Till then, bye.